Field Effect Transistor or FET. Welcome to Decreations Resources. Let's talk about Field Effect Transistor. Now, the name field, electric field, as we know, is related to voltage, and FET is a voltage control device, hence the name. So basically it relies on voltage and hence on electric field to control the flow of current and basically the conductivity. Now this is a unipolar device, that means there are only one kind of carriers, unlike BJT which is a bipolar device, so there are two kinds of carriers, electrons and holes. Here you have only one kind of carriers. Now it's a three terminal device, and the three terminals namely are gate, drain and source. It is the voltage VGS, voltage across gate and source, on which basically the current is dependent. So if you can recall, in case of BJT, bipolar junction transistor, you have collector current dependent on the current IB, and in this case, in case of FET, the current is dependent on voltage VGS, which is applied to basically the input circuit because it's applied across gate and source. Now, broadly speaking, there are two main types of field effect transistors, namely junction field effect transistor, and which is abbreviated as JFET, and MOSFET, which is basically metal oxide semiconductor field effect transistor, or insulated gate field effect transistor, which is abbreviated as IGFET. Now, in case of JFET, junction field effect transistor, again there are two subtypes, namely N-channel and P-channel JFET. Now, how is the construction of N-channel JFET is what we look at. So basically there is a N-type semiconductor bar with two P-type heavily doped regions diffused on opposite sides of its middle part. The P-type regions form two PN junctions. The space between the junction, that means the N-type regions, is called a channel. So there is an N-type channel and hence the name N-channel FET. Now both the P-type regions are internally connected and a single wire is taken out in the form of terminal, and that is called the gate. The electrical connections or ohmic contacts are made to both ends of the N-type semiconductor and are taken out in the form of two terminals called drain and source. Now, drain is a terminal through which electrons leave the semiconductor bar, and source is a terminal through which the electrons enter the semiconductor. Now, whenever a voltage is applied across the drain and source terminals, a current flows through the N channel. The current contains only one type of carriers, as we've already seen, it's a unipolar device. So here electrons, and therefore the field effect transistor, which is called a unipolar device, is different from BJT, where basically there are two kinds of carriers. Now, if you see the symbol of N-channel FET, there is arrow coming from the side of gate, and if it is pointing in, it is the N-channel FET. If the arrow is pointing out, it's a P-channel FET. Now, one important aspect in the operation of FET is formation of depletion region. Let's talk about it and also the operation and characteristics of FET in the next video.